Okay, this is just our final lecture of the semester. It's on Chapter 8. I've actually combined everything in Chapter 8 onto this one lecture. Again, I'm taking into account the fact that I'm on the committee for intermediate algebra on redesigning the objectives and the topics we're going to be teaching, and we tried to cut them down so we're not putting so many into one particular lecture. I'm also using a new setup I probably should have used before. I'm using a microphone here rather than the webcam microphone, and that's in hopes that the noise level will be cut down. I'm also using another type of video feed because I'm getting ready to do a lecture for the tutors on complex valued functions, and I got some feedback in a test video telling me that my mouth and my lips were out of sync with the sound. And I know lots of you all just listen and you don't look, but one of the reasons I have that right there in the corner is not out of vanity in any sense. I'd rather you not see me, I guess, but there might be people who are hearing impaired in some future course, and it's for them. It might benefit them. So let's go on. We've got a few problems to solve. Pretty simple. Many of these techniques you probably already know. And the very first one is the square root property. I'm not going to derive this property for you. We will derive it for you in college algebra. I'm going to give it to you, and we're going to be allowed to use it. So if b is a real number and x squared is equal to b, then x is equal to plus or minus. So this symbol right here is shorthand for plus or minus, meaning positive or negative the value. So remember, if we don't have any sign at all, for example, the square root of 25, there isn't a positive sign here. We always take the positive value, and the negative in front of it is just equal to negative what this is, and that's equal to 5. So we combine those symbols and they look more like that. So that's not a new weird symbol. It just means plus or minus. And we're going to be using this property an awful lot to solve equations which are degree 2 equations. So here's our first example. I'm going to make this just a little bit bigger if I can. That's too big. So let's do example 1. That'll be okay. I might undo it later on. Suppose we have x squared is equal to 50. So the important thing to know about this particular question is, unless this value here on the right hand side is 0, we're going to have two distinct answers. So just using the square root property directly, that says x is equal to either the positive value or the negative value of the square root of 50. But we're not done yet, because 50 is equal to 25 times 2, and 25 is equal to 5 times 5. So let's go ahead and simplify what's under the radical. X is equal to plus or minus. So 50 is equal to, here are my prime number factors. So 50 is equal to 2 times 5 squared. So that's 2 times 5 squared. So since the index on the radical is 2, that means x is equal to, I can bring the 5 squared out, and the exponent here, since it's even, that's the reason I can bring it out, is because it's divisible by the index, which is unspoken, but it's 2. And you don't have to do that step, but that's the rule I've taught you, and that's plus or minus the square root of 2. The 2 stays behind. We normally don't write it that way. we normally write the plus or minus in front. 5 raised to the first power is just 5. And this would be our final answer. But it's important you realize that x is two different values. It's either 5 times the square root of 2, or it's minus 5 times the square root of 2. And if you were asked, by the way, to find the solution set, I'm pretty sure my math lab wants you to put the negative first, and I don't like that because sets do not have any sense of ordering whatsoever. A set is defined by its elements in any order whatsoever, and by them requiring you, out of their incompetence to do the programming so it won't matter, by them asking you to put the negative first, it gives you the false impression that sets somehow have a natural ordering, and they do not. So let's go on. Enough of that. So here's another one. Again, just the square root property. It's going to be pretty straightforward. So I have x squared is equal to 32. So I'm just going to apply the square root property immediately. So that says x is equal to plus or minus the square root of 32. So we got to see if 32 can be simplified. So we'll do a factor tree. It's easily divisible by 2. You may already know this. So there's the factor tree. So at the very end of the branches here, we have our primes. So it means 32 is equal to 2 raised to the 1, 2, 3, 4 to the 5th power. So I'm going to go ahead and reflect that in my next rewrite. 2 to the 5th power. Now 5 is greater than 2, so that means I can do something. And why am I focusing on 2 here? Because that's the unspoken index. So I'm going to rewrite 2 to the 5th is 2 to the 4th times 2. And then that allows me to bring the 2 to the 4th outside, divide it by the index. What's left inside? 2 to the odd power, which is 1. So that gives me x is equal to plus or minus 2 to the 4 divided by 2 is 2 squared times 2. And my final answer is x is equal to plus or minus 4 times the square root of 2. So pretty much it's really the only work there was to reduce the number under the radical to its lowest of forms. Here, this one's pretty much going to again be straightforward. We're going to do the most obvious things. So I have 2x squared minus 14 is equal to 0. So I want to move the 14 over to the other side of the equation, or the equal sign, and it changes into a positive number. That's a good thing. And now what I can do is I can divide both sides by 2. And that's going to give me x squared is equal to, well, 14 divided by 2 is 7. And then that gives me, now I can use that new square root property I just mentioned. X is equal to plus or minus the square root of 7. Now since 7 is prime, there's no possible way I can do anything to that radical. It's in its complete simplified form. So again, we're playing with this theme. We got a theme and we're playing with it. These are variations on a theme. So I'm going to show you exactly what I mean by variation on the theme. Suppose I have w squared is equal to c. Then by the square root property, that means w is equal to plus or minus the square root of c. Here I have x plus 1 squared is equal to 12. So if I come over here, and I'm not expecting you all to do this, but if I come over here and I say let w equal to x plus 1, this is the same as w squared is equal to 12, which means w is equal to plus or minus the square root of 12. Well, I can go ahead and I can note that the square root of 12 is the same as 4 times 3. And I know that 4 is equal to 2 squared, or the square root of 4 is 2, so I can bring that out. I have w is equal to plus or minus 2 times the square root of 3. Now I'm going to replace w as x plus 1. And I'm solving for x, so I subtract 1 from both sides. Now the important thing to remember about this particular problem is that you understand what the solution really is. So let me come down here and give us some more room, straighten it out. So this means that x has two values. So x is equal to, we're going to take the top value first. Since it's plus, I don't have to write it. 2 times the square root of 3 minus 1. Or x is equal to minus 2 times the square root of 3 minus 1. So in a set form, my math lab would want you, I think, if I'm not mistaken, to write them that way. So that's the solution set. Again, when the power of x is 2, then normally we have two solutions. There's only one exception when we don't, and that's when x squared is equal to 0. So here we're going to use, again, the same procedure, but I'm going to extend this property. So we're not going to go and make any substitutions. We're just going to learn from what we just observed. And we have 2x minus 5 squared is equal to minus 16. So we're going to immediately apply, and what I'm going to do right here, we're going to extend I'm just going to write SR for square root property to include negative numbers. So here's just a specific example. So if I have x squared is equal to minus 4, then x is equal to plus or minus the square root of minus 4. But remember, we have another property that says that is equal to the square root of 4 times minus 1. Let's get us some more room here. And that's equal to plus or minus, well, the square root of 4 is 2 times the square root of minus 1. So that's equal to plus or minus 2 times I. So basically, we're going to go ahead and use the square root property even though we're taking the square root of a negative number. So in other words, the property extends to complex numbers. So let's going back up here, let's tackle this problem now. We have 2x minus 5 squared is equal to minus 16. So I'm going to take the square root of both sides. If you want, you can pretend like this is just the expression w is equal to 2x minus 5. So that says 2x minus 5 is equal to plus or minus the square root of minus 16. But you probably know that the square root of minus 16 is I from a property that we developed whenever we looked at complex numbers, very last 7.7 times the square root of 16. So that's 2x minus 5 is equal to plus or minus I times 4, which we normally write as 4 times I. So let's go ahead. So that means I've got to solve for x because that's what we're doing, right? So I'm going to add 5. So the plus or minus, here's the thing you have to remember, only applies to this quantity right here, 4 times the imaginary unit. Plus or minus 4i plus 5. So my 2x, if I divide both sides by 2, I get plus or minus 4i plus 5 over 2. So it's important you understand how this leads to two particular answers. So one answer is I take the top value, the plus. It's 4i plus 5 divided by 2. Or now I take the bottom of the signs. X is equal to minus 4i plus 5 over 2. So that's the reason I circled this right here. The plus or minus only extends to this quantity, 4 times I. So the only thing that gets the plus or minus change in my answer is the quantity 4i. In one case it's plus, and we don't bother to add the plus sign. And in the second case, it's minus. Okay, this is a great little problem that has to deal with interest rates. This is an applied problem. So we know that interest rates are going to be positive. Just keep that in mind. Because many times we will get two answers. One is positive and the other is negative. Not always. Sometimes they're both negative. Sometimes they're both positive. But it's not completely uncommon for one to be positive and the other to be negative. So find the interest rate R. So that's going to be our unknown. If $2,000 principal investment, so that's how much you invest at the very beginning, results in a return amount of $2,420 in 2 years. So how do you solve this? I actually give you the formula. Use A is equal to P times 1 plus R raised to the T. So the base, T is our exponent, and the base is 1 plus R, where A is the final amount. So in this case, it's going to be $2,420 after T years. So we have 2 years. So T is equal to 2. And P is the principal amount. So the principal amount is $2,000. And R is the interest rate. So let's go ahead and solve this. So we're going to be using A is equal to P times 1 plus R raised to the T. So R is our unknown. T is our time, and that's 2 years. Our P is given to be $2,000. And our amount at the end of 2 years is $2,420. So I'm just going to go ahead and do the replacement. A is 2,420, and that's equal to 2,000. That's my p-value. 1 plus r. I don't know what r is, but my t is squared. So notice how I anticipated that t was going to be equal to 2. The original just has a t right there. So what is the first thing we're going to do? We're going to try to simplify this. Notice this is a value. If you want, let w equal 1 plus r squared, or let w equal 1 plus r, and then this becomes 2420 is equal to 2,000 times w squared. But the first thing we're going to do is we're going to divide both sides by 10, not by 2. We could have divided both sides by 2, but we're going to divide both sides by 10. When I divide both sides by 10, that allows me to take off 1 0. So the result is 2420 is equal to 200 times 1 plus r squared. And now what I'm going to do is I'm going to divide both sides by 200. So 242 now, after I've divided by 10, divided by 200 is equal to 1 plus r squared. So we know that 200 is equal to 2 times 100, which is equal to 10 times 10. So that's what we're trying to do right now, is simplify. So 200 is equal to 2 times 10, which is 2 over 10 squared. So let's see what 242 is. 242, the obvious thing to do is to divide it by 2. And that gives me 121. And I hope you recognize 121 is equal to 11 times 11. So 242 is equal to 2 times 11 squared. So those 2's cancel out. And that gives me, that's equal to 1 plus r squared. So let's continue on. So 11 squared divided by 10 squared is 11 divided by 10 squared. We're using an exponent rule, is equal to 1 plus r squared. So now I'm going to use the square root property. So I'm going to take the square root of 11 tenths squared, plus or minus, and that's equal to 1 plus r. And if you're not comfortable with seeing it that way, you're completely fine to rewrite it as 1 plus r is equal to plus or minus the square root of 11 divided by 10 squared. And we'll just leave it in that form. So that's 1 plus r is equal to, so we know that our interest rates are going to be positive. So we're going to ignore any interest rates. So the square root of 11 tenths squared is either going to be plus or minus 11 tenths. So r is going to be plus or minus 11 divided by 10 minus 1. Here is the thing. If we take, this gives us two answers. R is equal to 11 tenths minus 1, which I'm going to write as minus 10 tenths, or R is equal to minus 11 tenths minus 10 over 10. And clearly this is a negative, and I'm subtracting another negative. So this particular expression right here is going to be negative. So I'm not going to worry about it. Our interest rates are going to be positive. So I'm just going to look at this interest rate right here. That's the one that's going to be positive. And that's equal to 11. I have a common denominator, minus 10 divided by 10, which is equal to 1/10. So that's my interest rate. That's equal to R. Notice I didn't have to grab my calculator. It was really simple. And you should know that 1/10 in decimal is 0.1. And that's my interest rate. Pretty simple. No calculator needed, used, or required. So here we have a brand new thing. Now when you get to college algebra, we're going to derive the quadratic formula. But for our new class, we're actually are just going to give it to you. Now this is for our new classes that start in the spring, but like I said, since I'm on the committee, I'm going ahead and giving you all the benefit of that foreknowledge now. So here is the quadratic formula. I have a feeling if this were a real class and I were to ask you to raise your hands, many of you would raise your hand because you're familiar with this. You get to use it now. But again, I want exact solutions. I don't want to see any type of decimal. This is not going to give you free rein to give me decimal answers. We want exact answers because deriving exact answers is math. That's the math that we want to focus on in this class. At any rate, suppose we have for real numbers A, B, and C. They don't actually have to be real numbers, but for you guys, it's always going to be real numbers. Indeed, even for college algebra, it's always going to be real numbers. So if we have an equation of the form A x squared plus bx plus c is equal to 0, then we know what x is. We have a formula, think about this, we have a formula to solve for x that is wholly given to us in terms of the coefficients of each of the terms in the equation. That's amazing. It's called a closed form formula for quadratic equations. Believe it or not, there was once a time in Italy in the Renaissance where there was no telephone, there was no internet, no electricity, nothing. Mathematicians were highly regarded, and there was national contests between Italians and other places in Europe for who could actually find closed form formulas for degree 2 equations, and that was done pretty quickly. They used an old Greek technique called completing the square, and we'll learn that technique when we look in college algebra. We'll actually derive this formula. Then the next one would be degree 3 equations, and they found a closed form formula for degree 3 equations, and it was hard. That was a major thing. Then degree 4 equations. Okay, well that's doable. What about degree 5 equations? And they looked 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 and they looked, and it was not until many centuries later that it was proven that there is no closed form formula that will give you the solution to x for equations of degree 4 or higher. So we've got the easiest one right now. It's a degree 2 and it's called a quadratic. So let's use it. So I'm going to assume that you all have copied that down and it's on your notes. I'm not going to go back and refer to it anymore because it's your job to copy that down on your notes if you don't have it memorized up here, so that you can look at it when I go on, because it's just too much to have to go back a page and scroll up and all of that. So we have 3x squared plus 16x plus 5 is equal to 0. And we're comparing that to our formula, ax squared plus bx plus c is equal to 0. So what do I need to use the quadratic formula? I need the values of the coefficients. A is equal to 3. B is equal to 16. And C is equal to 5. So then I come over here and I write x is equal to minus b. So b over here is not negative. If it's negative, then it has to bring its negative sign with it. Plus or minus. So you know somewhere in the derivation of this formula, they use the square root property. B squared. Well, b is 16, and we're squaring it. Minus 4, that's always there, times our value of a, which is 3, times our value of c, which is 5. And here is very careful. The entire thing, including the minus 16, is divided by 2 times a, which is 3. So now let's go ahead and we're just going to work on simplifying the right-hand side. So that's minus 16 plus or minus the square root of 256. That's 16 squared. And 4 times 3 is 12, times 5 is 60. All of this is over 6. Gives all kinds of room. So again, just the process of simplification. Now you've got it all plugged in. Here comes the math part. Plugging in numbers and formulas, that's not really math. Deriving the formula, that's math. But now that we got to simplify this, so 256 divided by 60 is 196. And I'm dividing everything by 6. Now, you should have memorized that 196 is equal to 14 squared. Now, if you don't have that memorized, you'd have to come over here and you'd start doing a factor tree. And you'd get it's equal to 2 squared times 7 squared. In other words, 2 times 7 squared, which is equal to 14 squared. So I have minus 16 plus or minus square root of 14 squared. All of this is over 6. So that's minus 16 plus or minus, well, the square root of 14 squared is 14 over 6. So that's going to lead to 2 answers. So let's find out what those answers are, and we're going to simplify them. And remember, what is it I'm developing here? X is equal to this. So the first is minus 16 plus 14 over 6. The second is plus 16 plus 14 over 6. I know I took the minus wrong. Let's do it right. Minus. There we go. Because it's not 16 that changes value, but 14 that has the 2 different values. So minus 16 plus 14 is minus 2 over 6, which is equal to minus 1/3. So there's one answer, minus 1/3. Over here, minus 16 minus 14 is minus 30. And I don't know what insanity possessed me to write 2 right there, but it did. And it's actually divided by 6. Minus 30 divided by 6, and that's equal to minus 5. So be careful there. It is, my notes, I have it wrong. Because 14 is what is changing sign. So our answers are, here we have an example of two negative answers. Because 14. Okay, let's go to the second problem. It's not as bad as it thinks. You see the fractions, and I can hear you just groaning. It's not so bad. And one of the reasons why it's not so bad is because we're going to set it equal to 0. That gives us an ability to do something that makes things really nice. So this is a quadratic equation in the variable m. 1/4 m squared. If you don't like it, change the variable to x, and then put it back to m at the very end if you're doing a MyMathLab problem. So what do? We want to clear the denominators. So I find the LCD of 4 and 2. And that's equal to 4. So what we're going to do is we're going to clear the denominators by multiplying both sides by 4. And that's the cool thing, is when I multiply the right-hand side, I still get 0. So here we have 4 divided by 4 is 1. 1 times m squared is m squared. 4 times minus m is minus 4m. 4 divided by 2 is 2. 2 times 1 is plus 2. And there I have my equation in a better form. So again, this time I'm going to look at a m squared plus b times m. All I'm doing is changing my variable x to m is equal to 0. So a is equal to 1. The leading coefficient is 1. That's great. B is equal to minus 4. Notice there's a negative in there, so be careful about that. And C is equal to 2. So now I'm just going to go ahead and give myself all of this space. So x is going to be equal to minus. That's inherent in the formula. So the b, which is minus 4, has to bring that minus along with it. It can't use the one that's already there. Plus or minus the square root of b, which is minus 4 squared, minus 4 times a, which is 1, times c, which is 2. And that needs to be extended. The radical sign goes over all of this part, the b squared minus 4ac. And all of that's going to be over 2 times a, but a is equal to 1. So let's start simplifying. Minus a minus 4 is 4. Then I have my plus or minus. Minus 4 squared is 16. Minus 4 times 2 is minus 8. All of this is going to be over 2. So this is going to be 4 plus or minus the square root of 8 over 2. Well, the square root of 8 is 4 times 2. 4 is 2 squared. So the square root of 8 is equal to 2 squared. Sorry, don't mean to be writing so small. 2 squared times 2. So it's equal to 2 times the square root of 2. So here we want this in the full simplified form. So we're going to do it in 2 steps. One is we have 4 plus 2 on the square root of 2 divided by 2. But that's equal to, in the denominator, 4 and 2, they share the common. I can factor out a 2. So that's equal to 2 plus 2 on the square root of 2. And once you have that done, you can immediately say the other is 2 minus 2 on the square root of 2. So those are my two answers. So all you have to do, once you got it into simplified form, then you just notice that whatever the radical is, it's going to be plus or minus that radical. That gives me the plus, and this gives me the radical. Now I just want to show you another way you could have got this particular answer, since this is intermediate algebra. So remember that A plus B, it's a property of fractions that I feel we always need to discuss. A plus B divided by C is AC plus BC. That's going to work here as well. So that's going to be 4 divided by 2 plus 2 on the square root of 2 divided by 2. Well, 4 divided by 2 is 2, and 2 divided by 2 is 1. So that's another way to get to there. Another variation on a theme. So here I have x is equal to minus 3x squared minus 3. So I want to get it in the form ax squared plus bx plus c is equal to 0. And I would prefer that my leading coefficient a not have a negative sign. So what I'm going to do is I'm going to move these terms on my right-hand side to the left-hand side. That gives me 3x squared. The plus x stays, and the minus 3 becomes plus 3, and that's equal to 0. So again, reminder, this is ax squared plus bx plus c is equal to 0. So my a is 3, b is 1, and c is 3. So now let's use the quadratic formula. So x is equal to minus b. b is 1, so it's minus 1 plus or minus, here comes the square root part, b squared, that's 1 squared minus 4 times a is 3 times c is 3. All of this is going to be over 2 times a, which is 3. So let's go ahead with this. This is minus 1 plus or minus the square root. 1 squared is 1. 4 times 3 is 12. 12 times 3 is 36. 2 times 3 is 6. So that's minus 1 plus or minus the square root of minus 35 over 6. But remember, our solutions in this case are going to be complex. So that's equal to plus or minus I times the square root of 35 all over 6. So that gives us two answers. 1 plus, I prefer the square root of 35 times I. Just make sure your I is not underneath the radical. Or x is equal to 1 minus, oh, that's all divided by 6. Sorry, we can't forget that. That's 1 minus the square root of 35 times I divided by 6. And there's nothing else you can do. Now, if you want to, the book is fine with putting the I first and the real number here. The reason I don't like that is we clearly state in standard form a complex number z is equal to a plus b times I, where a and b are real numbers. In this case, we have, that would be minus 1/6 plus the square root of 35 divided by 6. Both of these are real numbers times I, or minus 1/6 minus the square root of 35 divided by 6 times I. So that would be my A minus BI in this case, A plus BI in this case. Here you would be writing it A plus IB. And I know it's the same. I times B is the same as B times I, but whatever. Do it however you want. So let's go another, we're already to there. So the next page is I'm going to introduce to you the Pythagorean Theorem. So this is the strong version. I'm giving you a strong version. So if we have a triangle, we have 3 different sides. They could all be equal in length, and that's the case there in equatorial triangle, and they're never right triangles. But a triangle is a right triangle if and only if, and just ignore this little, we denote a triangle as a right triangle by putting that little b square right there in the corner, in which case the A and the B are the legs, the sides adjacent to the vertex, which is 90 degrees, and the side opposite the 90 degree is C, is called the hypotenuse. So if we have a right triangle, then the legs, the shorter of the 2 sides, if I square them and add them together, then I get C squared, or A squared plus B squared is equal to C squared. I don't know if I've told you, but I'm sure you've seen Wizard of Oz. I mean, I grew up with that. I mean, that came out when my mom was young, a girl, and I mean, like maybe 8 years old or something like that. So we watched Wizard of Oz the entire time, and you know, the scarecrow doesn't have a brain, and then the wizard gives him a certificate, a PhD, saying he has a brain, and he points to his straw hat, and he says, the sum of the sides of an isosceles triangle is equal to the square of the opposite side. And that's wrong. What's wrong with it? He said isosceles triangle instead of right triangle. So here's the question. Is that an indication that he really doesn't have a brain? That getting a PhD didn't change anything? Is that what the writers wanted to say? Or my favorite answer is, it just shows the writers in Hollywood don't know math. They never fact checked. It sounded right to them, they put it in there. At any rate, so we have a piece of property that has the shape of a right triangle. That means Pythagorean theorem is going to hold. The longer leg is 20 meters longer than twice the length of the shorter leg. So let's write this down. So let x be the shorter leg. Let's actually draw us a picture. There's going to be a short leg and a longer leg. And this is going to be the hypotenuse. So it's kind of nice. Let's draw. X is going to be my shorter leg. And the longer leg, this one down here, the longer leg is 20 meters longer is equal to 20 meters longer. So I'm going to add 20 meters to the length of twice the length of the shorter leg. So if the shorter leg is x, then twice its length is 2x. So that's 20 plus 2x. The longer side, which is the hypotenuse, is 10 meters longer than the longer leg. So it's 10 meters added to the length of the longer leg. So that's equal to 30 plus 2x. So we have our setup. So we know by the Pythagorean theorem, this is the right, this is the part, these are the two legs, x and 20 plus 2x, and the hypotenuse is 30 plus x. So by the Pythagorean theorem, I have x squared plus, in parentheses, 20 plus 2x squared is equal to 30 plus 2x squared. So let's work this out. So this is my formula. It's going to result into a quadratic equation. So this is x squared. Now using special products, 20 plus 2x squared is 20 squared. 20 squared is 400. The middle term is 20 times 2x times 2. Well, 20 times 2x is 40x, times 2 is 80x, plus 80x. And then my last term is 2x in parentheses squared. And we're going to use the same thing over here, special products. 30 squared is 900. The middle term is 30 times 2x, which is 60x, times 2. And then I have 2x in parentheses squared. So the nice thing about this is that I can subtract, it didn't turn red, I can subtract 4x squared from both sides. So that's x squared plus 400 plus 80x is equal to 900 plus 120x. So let's bring everything on over to the left-hand side. So that's x squared. That's what's over here. Minus 900 minus 120x is equal to 0. So now we want to combine like terms. I'm going to combine like terms and do some simplification at the same time. So 800x minus 120x is, that's not 800x, sorry, it's just old 80x. So 80x minus 120x is minus 40x. And 400 minus 120 is 400 minus 120 400 minus 900. There we go. 400 minus 900. So notice I've taken, the problem there is I got confused. What I normally do is when I do this is once I put something down, I mark them out. And I was looking at the 120 and the 400, and I was looking at my notes and I knew something was wrong. That's the reason it's important that I do these beforehand, because when I'm talking, I will sometimes make these mistakes. So 400 minus 900 is minus 500. And that's equal to 0. So let's go ahead and solve this. So I have ax squared plus bx plus c is equal to 0. So a is equal to 1. That's always nice. B, be careful, is negative. So whenever you get a negative b, take notice. And c is equal to minus 500. Doesn't really matter for c being negative. So that means x is equal to minus b. So minus a minus 40 is 40. Plus or minus our square root of b squared minus 4 times a times minus 500. That's going to be nice because it's going to turn out I'm just going to be adding instead of subtracting there. Over 2 times a, that a is equal to 1. So that's 40 plus or minus the square root of 40 squared is the same as 4 squared times 10 squared, which is 16 times 100, which is 1600. And minus a minus is plus. And 4 times 500 is 2000. All of this is going to be divided by 2. So down here, this is 40 plus or minus the square root of 3,600 divided by 2. So you know that the square root of 36 is equal to 6. So the square root of 36 times 100 is going to be 6 times 10. The square root of 36 times the square root of 100, which is going to be 60. So this tells us that x is equal to 40 plus or minus 60 divided by 2. So we're going to get two answers. 40 plus 60 divided by 2 is 100 divided by 2, which is 50. The other is 40 minus 60 divided by 2, which is minus 20 divided by 2, instead of trying, which is minus 10. And these are values of x. And what does x stand for? The length of the side of a triangle. So length is always positive. So we only accept the positive answer. X is equal to 50. But we want to know the sides of the triangle. So we go up here and we start writing them in. So one side, x, is equal to 50. The other side is 20 plus 2x, which is 20 plus 100, which is 120. And the other side is 10 more than that, which is 130. So the sides are 50, 120, and 130. And that's all we're going to do. I actually took another. This is actually from, I think the problem I just gave you there is from college algebra. It's an intermediate algebra type of a problem. And this is actually given in your book. And the reason, I will tell you the answer if you want to go and try to do it. But the reason I had to change it, in the book, they're expecting you to use your calculator. And you're not allowed to use calculators here. And I actually changed the problem to say find an expression that indicates how many feet of walking distance. So let's set this up, and then if you want to do it, because everything has to be kept as a radical. But there is something to be said about this problem that we can do without going into it. So here's our problem. This happens all the time in every college or university I've ever been. Students always take the shortest distance to get anywhere. And some colleges say, stay off the grass. Other colleges are smart, and they literally put sidewalks where students walk. Most obvious thing they should do. So students are walking this way because it's shorter. Some stay off the grass and walk this way. Well, they want to know how much longer it is if you walk the long way than it is the short way. So the first thing, this is the only thing I want you to do, is to get a guiding equation. So the longer distance, sorry, those should be two words, minus the shorter, and I'm not even going to bother to write distance, is equal to extra walked distance by taking the longer route. That's what you want to know. So the longer distance is x plus 20 from the diagram, because it's this length x plus this width x plus 20, and the shorter distance is giving to us to be 50. So to solve this, what you have to do is, again, just make a little diagram of a right triangle. It doesn't have to be perfect, where one side is given to be x, and the other side is, do they say x plus 2? That's x plus 20. X plus 20, and this is 50. So by use of the Pythagorean Theorem, we want to solve x squared plus x plus 20 squared is equal to 50 squared. And when you do it, you're going to find that one of the answers is negative and the other is positive. So you want the positive value of the x. And if you do this, and it's just if you're bored, and I know none of you will do it, but x is going to be equal to 2 times minus 10 plus 5 on the square root of 46. So I think that's equal to x. No, that's not equal to x. Sorry, I'm giving you the final answer. And the final answer is extra distance. Extra distance. And then I'm going to subtract from that minus 30. And that turns out to be, so there's going to have to be a lot of simplification done, right? So that's going to turn out to be about 17.82 feet, or about 18 feet longer if you go by the sidewalk. Okay, that's the last lecture of the course, and again, if you have questions about any of this, the last homework has been combined into one single homework called Chapter 8, and that's it until the final.